Okay, so we have to graph this function, the cube root of x plus 2 plus 3, figure out its transformations, find any intercepts, and find its domain and range. So first off, here's what the regular y equals the cube root of x looks like, right? And say if I plug in x equals 0, well, cube root of 0 is 0, x equals 1, cube root of 1 is 1. Then the next perfect cube would be 8. If I plugged in 8 for x, I would get 2. Cube root of 8 is 2. Similarly, negative, if I plugged in negative 1, I would get negative 1, or negative 8, I would get negative 2. So this is kind of the general shape of the graph. Now here are the general form for transformations. I use A, B, H, and K to represent the transformations. A is the vertical stretch, or expansion or compression. B is the horizontal stretch or compression. H is the horizontal shift, and K is the vertical shift. And so here I compare this to my equation, and I see H must be negative 2, because then x minus negative 2 would be x plus 2. So I find it's negative 2. That means, because it's negative, it means to the left, in the negative x direction. So I shift 2 units left. And also K is 3, because you can see K is 3. So it's positive, so it means I'm shifting 3 units up. And so now I can kind of compare the coordinates of the base function with the transformed function I have here. And you can see any x coordinate I have here is going to be x minus 2, because I take the coordinate, I move it 2 units to the left, in other words, subtract 2, and it's going to be y plus 3. In other words, I take any y coordinate and I add 3 units. I shift it 3 units up. So here are those points that I mentioned earlier. And all I'm going to do is I'm going to plug in the x and y coordinates in for this, x and y here. So negative 8 becomes negative 10, negative 1, negative 3, negative 2, negative 1, 6. Same thing here. I'm going to add 3, so you can see how these points change. And then I'm just going to plot these points. So here's negative 10, 1, negative 3, 2, negative 2, 3, negative 1, 4, and 6, 5. So 6, 5. So this is the graph, or the sketched graph, and you can see how all it is compared to the original is shifted 2 units to the left and 3 units up. So you see this point right here is the same point here, it's just moved a bit, because due to the transformations. And now to find the intercepts, we have to find, well, first off, let's find the y-intercept. Where does it intersect the x-axis? You can see it definitely does. You can see it crosses there. But at what specific y-coordinate? We know the x-coordinate is going to be 0 because it's on the y-axis, but what specific y-coordinate is it going to be? Well, all I have to do is plug in 0 for x in my equation, and then solve for y, or in this case f of x. They're the same thing. So plug in 0 for x, I figured out what y is at that point, and that's going to be my answer. Here I get the cube root of 2 plus 3, which is, if you plug it into your calculator, is approximately 4.26. So in other words, when x is 0, y is 4.26, and you can see how 1, 2, 3, 4, it's kind of around there on my sketch. Now to find the x-intercepts, I have to find where y, the y-coordinate, is equal to 0. And so you can tell this is not going to approach the x-axis, but down here in the negative direction, maybe if I keep going out, it's eventually going to touch the x-axis. So all I'm going to do is I'm going to plug in 0 for, well, y, or f of x, and then solve for x. In other words, what x-coordinate, if y is 0, what is the x going to be? So I move the negative 3 to the other side, I cube both sides, and then I subtract 2, and I get x equals negative 29. So the point negative 29, 0 is my x-intercept. And you can see how that makes sense. If I keep going, eventually, maybe out here, if I extend this axis, at negative 29, it's going to touch the axis, the x-axis. And the domain and range for cube root functions is going to be x is all real numbers, or in interval notation from negative infinity to infinity. And the range is the same thing, negative infinity to infinity. Because you can see I can plug in any x value across this graph, and I also can get any y value going up and down.